Hello, Marauders. And today I shrunk down to hide in the grass because all this trigonometry is getting kind of weird. But today we're going to get into section 4.2. And let me just show a little bit about this here. And today we talk about, here it goes, the unit circle. This is a huge thing, and you're going to have to know all about this. So this big circle here, okay, and you probably know what all these other little numbers all over the place, and why is there a big chart here? Well, there's a lot more to trigonometry than triangles. Okay, so where to start and explain this is always kind of a challenge, and there's all this little stuff. You have to know all this. If you memorize it, you're going to make your life so much easier. You're like, memorize this? Yes. So I'll try to explain this the best I can. But trigonometry is so many things. You go, what's with this beach? Well, the tides that go in and out. Talks about high tide and low tide. Even they have something to do with this. Okay, so today is all about the unit circle, 4.2. This is a 2-day lesson also. What we're going to do is take graph paper, which has, of course, X and Y, and a circle, and put these together. So in other words, let's mark this. And it's very important that you really understand what's going on. Otherwise, every section after this, through the next 3 chapters, you're going to be like, what are they talking about? Okay, so here's a piece of graph paper. And to make it simple, they call it unit because we're just going to do a unit of 1. So let's go up to 1, like right here. Here's 1, 0, right? The X is 1, the Y is 0. And let's go over here, do the same thing. Go to -1, 0. There we go. And we'll go up here to 0, 1. So very important. Don't get them backwards. I know it seems silly, but very, very important. And go down here to 0, -1. Okay, so we went up, down, left, and right. And let's make a circle. Yeah, a circle. So let's make a circle. So this is how I draw a circle. I go 1, 1, 1, 1. And then I'm going to draw a circle here. And trying to do this under the camera. Here we go. There we go. And there's a circle. Okay. And remember we did the whole thing with all the angles. So we were doing things like this and making the angles get bigger and bigger and bigger and bigger. Okay. Like there's 90 degrees, right? Okay. So how about I do this? And I'm trying my very best to not get you lost. So if I were to pick an angle, I don't know, how about here right in the middle, right? 45 degrees, that means I went 45 degrees. Or I could do it in radians. Instead of 45, I could say pi over 4, right? And of course, that means the outside here, this arc is 45 degrees. We learned about that. But what if, here's what I would like to know. What are the coordinates right here? Like here's 1, 0, right? And here's 0, 1. What's this? And you might be say 1/2, but it's not 1/2. So let's get a little closer here. I've redrawn this with a nice, better piece of graph paper, okay? And once again, let's make this, let's call this point out here 1, 0, okay? Here's 0, right at the very center, right? And of course, if you go up, this dot right here is 0, 1. Put a little parentheses on so you know you're talking about XY coordinates. And of course, way down here would be 0, -1. And over here would be -1, 0. Of course, this is X, this is Y. So if I put an angle on here, that's what you see on this little sheet. I'm trying to draw a little triangle here. And so if I pick something like, well, let me get my protractor here. It just disappeared. I did 45 degrees, didn't I? So let's get this really, really good. Here's a protractor. Let's get right there in the middle of 45. Looks like it's right 45, right there. Okay, there's 45. And, well, this doesn't look like it's quite on a spot, does it? And I'm wondering what the XY is. Well, if I were to do something like in metric here, now I don't know what this lines up with. See, it doesn't line to that. Oh, yeah, that's right. I'm trying to get some room here. And you know, it's like kind of like, well, it doesn't really line up. Ah, wait, there's 4 of these boxes for every inch, is there, on my paper? So if I count these boxes, I actually made this nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay. So this would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then there's the full dollar, okay? Same with going up, 0.1, 0.2, 0.3, 0.4, 0.5. This is a huge lesson. So I'm going to try to do as much as we can without taking too much time. That's what we do a little bit today, a little bit tomorrow. This continues section 4344. Okay, so now if you looked at that, let's try to line it up. 1, 2, 3, 4, 5, 6, 7. 0.7? Or is it a little bit more? It's something about 0.7, right? Not exactly. And the height, well, the height's also 0.7, isn't it? Okay, 0.7 and 0.7. Of course, not exactly. And of course, because this was 45 degrees, because I went exactly right in the middle there, didn't I? There we go. That was 45 degrees, wasn't it? I'll write 45 next to it right here, so you know what that was. What if I picked a different number? Now, here's something pretty cool, but let me get a different number here. Let's pick something small. Let's pick something a little easier. Okay, now you might say, well, that's going to be kind of hard to do. What they're going to ask you in the homework is to tell me these x and y coordinates of any angle. So somebody comes along and says, hey, I got a 45-degree angle for you, or an arc of 45 degrees. What are the x and y coordinates? And you'd say, well, 0.7 and 0.7. Okay, maybe you don't quite get that yet. Let's do a different angle. Let's try something really small. Let's try 10 degrees. Okay, here's 10, right? 10's about right there. So let's do this here, and I'm just going to draw this like this. Okay, there's 10 degrees, right? 10 degrees isn't much, is it? And I say, okay, what are the coordinates right there? And once again, it's kind of hard to read, isn't it? You're like, well, it's not quite 1, is it? If you line that up, maybe if I use this right here, kind of line this up. See, here's where 1 is. It's just a little bit in, right? I'm trying to make like a big dot right there for you. So it's a little bit less, isn't it? Like 0.995? 0.9 something, right? I'm really kind of lost, right? It's hard to tell. How about the height? Well, 1, 2, a little bit more, 0.2 something. Well, guess what? This is where the calculator is going to help you. There's a button on the calculator that's going to tell you exactly where that's at. And this is what you got to know. And it's in the book, and it's also right here. Check this out. And I put it also here. It's here, here, here. If you want to know, see, now look at my little drawing. There's a little angle. Okay. And this R, the radius is 1. Oh, yeah, let me mention that, because we said, well, I don't want to use something like that. Let's go like this. How about this clothespin? Say this clothespin has a length of 1, right? No matter where you're at the circle, the radius never changes, does it? Okay, that never changes. Like this here. See that? The radius is always 1, isn't it? The radius is always 1. But this little coordinate right here, if you want to know the x coordinate, you press COS on your calculator, which is short for the word cosine. And so we say the cosine, the x is the cosine, and the y coordinate is the sine. That's why it's also over here, cosine and sine. Okay, it's also right here. Cosine is x and sine is y. I know there's all this other stuff on here too, isn't there? So check this out. You're just going to look like this. You press cosine, COS. Okay, I'm going to write that for you. Oops, I'm too zoomed in. Okay, I'll get that in a moment. COS. Okay, let me get a piece of paper here. Okay. COS stands for cosine. Okay. And SIN stands for sine, because just people don't feel like writing the whole word. And the cosine tells me the x, and the sine tells me the y. And how are you going to remember which one's which? Well, x comes before y in the alphabet, doesn't it? Well, doesn't c come before s? How about that? Okay, now watch this. Cosine, and we had 10 degrees. Watch this. Press 10 degrees, and make sure your calculator is in degree mode. I'm going to press 10, close it, and it says there's what it exactly is. Sweet. And we like to use 3 decimals. Whenever you have tiny numbers, you should use 3 decimals. So 984, maybe we should round to 985. Okay, 985. And you want to know the y coordinate? Then press sine, S-I-N. You press sine, 10 degrees, close it up, and there it was. Oh, I said 0.2. It wasn't quite 0.2. I guess I didn't draw it very well. I guess it was a little less than that. See, I didn't draw it too well, did I? It's hard to do, isn't it? Maybe if I measure that again a little bit better. Oh yeah, look at me. I did 12 degrees, didn't I? Pretty sloppy. Okay, so 0.17. Oops, I'm off the screen there. 0.174. We'll use 3 decimals. Most people like to use 3. In fact, let's go back and try this angle. Cosine 45. I'll close it up. Remember I was guessing 0.7? To be more exact, it's 0.707, and they're actually both the same. If I do sine of 45, it's also 0.7. And okay, now let me do another one here. Let's do one more. Oh, and let me go ahead and mention something on this. One thing to get the calculator to work, you have to make sure it says D up here for degree. Now, how do you do that? Different calculators are different. Sometimes it's under, I'm not sure where it is under this calculator. But yeah, on this calculator, every calculator is different. See where it says setup, shift, setup, angle unit. And see, do you want to use degrees or radians, or that one that's out of 100 gradians, but nobody uses that. So I'm going to make sure it's in degree, and see it's got a little D. But the biggest mistake students make is they get all their answers wrong is because they were using the wrong unit. Just like if you were measuring in inches and your friend used centimeters, you'd get all confused, wouldn't you? Just like if I went, shift, setup, angle, radian, this has a little R. I don't want to do that, because if I do that, I'd have to type them in a little different. You go, what do you mean? Well, watch, it's in radians right now. Remember 45 degrees? Pi over 4, you'd have to go like this. Cosine pi divided by 4. I see I put in radians because it's in radians, and look what's at 0.707, right? See? Pretty cool. I didn't enter 45, I entered that, but you got to tell it which unit you want to use. I want to go back to degrees. Now in the homework, sometimes they're going to ask you this one. If they ask me that, I usually just look at my sheet and go, pi over 4, I'm going to enter 45. It's just easier to type in, because some of you might have trouble typing that in. So let's put this back in degrees. Number one mistake, wrong unit. See it all the time. Okay, I'm in degree. Okay. Oh yeah. Okay, so and speaking of this, I'm going to draw a little triangle here for that 10 degrees one we did. What if I did this and drew a little triangle, little right triangle, little Pythagorean theorem? Remember a squared, b squared, c squared? This is the same thing. This side down here on the bottom is the one we said was 0.985. That's x, isn't it? Because isn't that that length was 0.985? That's the x length. And so just remember, cosine tells you that side. That side is that coordinate. Well, it makes sense. If you go over 0.985, this side is 0.985. That's why that's the coordinate. Likewise, we do the y, the height here. That height, well, it's right here. It's 0.174, isn't it? That's the y. And we used sine for that. So some people also say this is cosine and this is sine. So cosine is the x, sine is a y. You just got to memorize that. And if you can't memorize it, see, you use Newell's great sheet. Cosine is x and sine is y. And that's why I didn't tell you here. You go, what's this? I'll get to that. Okay. And if you actually did the little Pythagorean theorem, you go, what? Pythagorean theorem? Remember a squared, b squared, c squared? If we took this side, this 0.985 and squared it and added the y, 0.174, or 74 and squared it, it equals, and then of course I got to take square root of that answer, 1. Now, why is this not exactly 1? Because we rounded, right? That's the hypotenuse. And the hypotenuse is the radius. So the equation for a triangle, a squared, b squared, c squared, or in this case, x squared plus y squared is the radius squared, is the same equation, isn't it? And that's why you're also going to see this thing here says Pythagorean theorem. It says sine squared plus cosine squared is 1. Now what's with that? Isn't that y squared plus x squared is 1? That is the Pythagorean theorem in disguise, because cosine is the x and sine is the y. X squared, y squared, and 1. Okay, so let's try another one. Let's do one more on here. Let's do 30 degrees, because 30 degrees is a popular one. Now, why is 30 so popular, not like 20? Well, 30 is 1/3 of 90. So a lot of people like to cut things in 3. So let's go to 30 right there. There's 30, right? So you can draw the triangle. There it is. Boop. Okay. So what are the coordinates of that guy? And so remember, when you say his coordinates, this here is the x, and this here is the y, isn't it? And the radius is always 1, because we're using what we call a unit circle. So let's find out how far this piece is, or that coordinate. Okay, oh, I got it. Cosine, and we're doing 30, right? We're doing 30 degrees. 30 degrees, so that's just cosine of 30. 0.866, okay, 0.866. Okay, that pen's a little not so great, but try this one a little better. Try getting green. 0.866. And how about the height? Okay, y, sine is the height. Sine of 30, whoops, 30. And I got, oh, that one's exact. 0.5, okay, 0.5. Okay, let me go back to something here. Let me go back to cosine of 30. Okay, now on my sheet, I have all the answers too. Here's the popular ones. Here's the answers for 30. You go, wait a minute, wait, well, these look a little funny, don't they? Okay, remember I said 0.5? Well, that's a half, isn't it? Well, what's this? Some people are into radicals, right? My calculator said cosine of 30 is 0.866. Do you see I've already written in the popular ones for you? 30, 45, and 60. Of course, here's 0. But why did I write that? Well, watch this on my calculator. I'm going to press this little fraction button. Oh, did you know the square root of 3 divided by 2 happens to be 0.866? These are not in decimal form, they're in radical form. What's this one? Let me go back to 45, cosine of 45. Remember I said 0.707, but my sheet says this. Well, if I hit my fraction button, there it is. So I could go back and forth. These are the same thing. That reduces to that. So that's why this has these little things. You know, why do they do that? I know, it's weird, okay? Okay, so so this sheet definitely helps you. The book has this kind of hidden around in different blue tables. And so they put some things like in little tables that really get you lost, okay? Really get you lost. But they did put some little charts of some of the things, and it just makes it difficult. That's why you definitely want this sheet. Okay, so let's try a fresh one. Okay, so sometimes they're going to say, here's an angle. Let's say we've got pi over 6 is our angle, right? And they might say, can you please tell me the x and y coordinates for pi over 6? And you're like, pi over 6, okay. I'm going to go like this. I'm going to draw a picture. And, okay, pi over 6. And if you go, oh, how many degrees is pi over 6? I forget. Okay. And there's tricks to memorizing all these, which I'm not going to get into because I'm not going to require you to memorize these because you can just look at your sheet. Okay, pi over 6 is 30. But you know, I knew that. You know how I knew that? Because that's 1/6 of pi. What goes into 180 6 times? 30. Oh, 30. 30 goes in there 6 times. That's 1/6 of pi. But anyway, 30 degrees. Okay, so it's over here. It's in the positive part of the paper. Okay, so if they say pi over 6, I'm going to go over here, pi over 6, and I go, oh, okay, that's 30 degrees. That really helps me out. Totally going to help me because you're going to have to know the quadrant. Okay, so this is a 30-degree angle, right, in that direction. So I'll make a little triangle, and they want to know the coordinates. So wait a minute, how am I going to, oh, okay, oh, I know what to do. That's right. How do I get the x and y? That's right. This is the cosine. This is the sine. And what's the angle? 30. So remember, all you got to do, if they say pi over 6, I go, oh, 30 degrees. Okay, so what's the cosine? Cosine of 30, 0.866. But if you want to do a fancy style? Radical 3 over 2, right? Okay, which one should you put? Sometimes a book puts that. Sometimes a book puts that. Oh, boy. I'm going to put the radical 3 over 2 here for right now. And I'll just put it as the 0.866 underneath. Okay, and let's do the sine. Sine of 30, because the sine gives me the y, 0.5. Oh, well, 0.5 is 1/2, or is a decimal 0.5. Some people put 0, 0 to tell people they didn't round it off. Okay, notice they're both positive. Okay, so there's my answers, right? There's the cosine, there's the sine. Some of the questions in the homework are just going to say, like, what's the sine of pi over 6? And it's like, oh, the sine is the y 1/2. Can't I just punch these in my calculator? Yeah, except you're like, well, how do you punch these in? So like what I do, 5 pi over 6, I just kind of go, 5, let me type in 150. Okay, that's what I do. Or if you get one you don't like, you can do that conversion. Or, remember, for this one, I could go cosine 5 pi over 6. So let's say it was 150 on my sheet. And there it is. My calculator does this. Most people's calculators aren't going to do this neat fraction trick. And wait, that's a negative answer, isn't it? What's going on here? Let me explain that. What's going on with the negatives? And of course, if my calculator, once again, if my calculator were in radians, I do have the ability to go 5 pi, and you have to use the pi button. Okay, find pi on your calculator. See, if I entered it like that and I wanted to enter the radians, see, it still works. And there it is. But why is it negative? Okay, so the next thing we have to understand is positives, negatives. So as I said, there's a lot here. You can't learn it all at once. Okay, let's go back to this. Remember how this is graph paper? Aren't on a piece of graph paper, or like here's a graph paper, isn't over here, aren't these positive on graph paper? It's like if I made a piece of graph paper like this, and I put a little dot over here, aren't you gonna go like, oh, that's like a 6 and I don't know, 4, isn't that like 6, 4? But what if you had an angle bigger than 45? What if you went like past 90 way over here? And you had a big angle, right? Went all the way over here, right? What do you notice about the coordinates over here? Well, just like this little piece of graph paper, if you were over here and you did a big angle all the way over here, isn't x positive here and x negative here? Wouldn't this be a negative answer? But it's still up where it's positive. So you got to think about graph paper. Over here, you're going to have negative and positive because this is the x and this is the y. This is the x and this is the y. Over here, remember on this side of the graph paper, x is negative, like a number line, positives and negatives. Once you go like -1, -2, -3, -4, these would be negative. So if you put in something like, and let me get back to normal degree mode. If I go like cosine of 150, see 0.866, it's negative. It's trying to tell me this answer is negative. That's why I'd say negative 0.866 for like 150 degrees. And the y coordinate was still +5 because the y is still up. And likewise, if you kept going a little farther, down here, what do you notice about the coordinates down here? Well, negative here. Remember, here's y, here's x. So when you get down here, they're both negative, aren't they? Like that. So now they're both negative because you're like -6 and then maybe like -4 or something. So let's wait over here. We say they're both negative. And if you went really, really far, all the way over into here, here's your dot. Aren't you back like at positive because you're over x, but the y is down? And that's what you see here, is that you might notice that these answers are the same ones here, the same ones here, and the same ones here. Just that these are all positive. See, I said they're both positive. Well, over here, the cosine's negative because the cosine's the x. Isn't x negative this way on a piece of graph paper? But the sine is the y. So these three answers here are right here. They're just negative. And these are the same. See, 1/2, 1/2, radical 2, radical 2, radical 3 and 2. Same numbers, right? Just that these are negative. And if you're down here, see, they're both negative. Same numbers, just negative. Your calculator will do this all for you. And lastly, over here, the cosine is positive and the sine's negative. Okay, so we're going to kind of end here for today because that's enough. But you still can't do everything. Like right away, you're not going to be able to do number 1. You're like, what? I can't do number 1? No. Let's show you that tomorrow because they're doing it backwards on you. Okay, how do you go backwards, right? Okay. And so I'm going to explain this number 1 tomorrow, how I did all this, okay? But you can actually go to number 5 and start just doing all of these, okay? So looking at the homework, you won't be able to start with number 1, but you can go right over to number 5. And of course, I would say print out this sheet. It's on my Canvas site. If you're at school, I give you one. Or you can try to look at theirs. You can also Google unit circle, the name of this unit circle. You could Google this and find one and print one out too. So you can do all these questions. And in fact, to save you time, they say you could look up here, but they didn't quite complete the labeling. Once again, you want the chart. Okay, so you can find them all. So you can either use the chart or you can use your calculator. Okay, so you can get through all of those. And that's what I did here. Now, sometimes they ask some other buttons, right? Tan. And some of these you might not know how to type in. I'll talk about that tomorrow. And you do what you can. If you're like, don't get it, that's all right. You have to kind of get more stuff and go, what are you supposed to do down here? Okay. What is this? Some of these questions don't make sense to you understand more about unit circle. Okay. But we're going to stop there, see what you can do. But like I say, tomorrow we'll get a little bit more and it'll make more sense. Right? Because right now, some of you are like this. Huh? Okay. But don't worry. It will make sense and you got your sheet. Okay. So that's it. I don't want to take up too much of your time, but we'll wait till the next lesson.